Okay. So last time, what did we do last time, right? So this was the question. And I told you guys, let's try together. So try this, let the launching angle and speed be 30 degrees and 50 millisecond, 50 milli per second, 50 meter per second, milli per second. Find the time and height at the highest point. So first thing that after I read the question, what I did was I tried to visualize how the projectile motion is. So the information given here is 30 degrees and 50 meter per second, right? So immediately I know my V naught is 50 meter per second and it's 30 degrees. And I start from down here. It doesn't say that I start from the top. It just says a launching angle. So I just assume that we are starting from the bottom. And then bila kita start pada bottom, kita akan go through a period yang velocity kita positif. Our displacement is going up and our S is positive. And then it comes to a point that when the V becomes 0, this only happens when we have up and down motion. Kita akan find this titik called V equals to 0 or the maximum height. But this is not the same as maximum range. Range refers to the displacement in the X over here. So that is your range. This guy is called your capital H. What do you call it when it's not the maximum height? You call it Y or S. What do you call it when it's not the range? You just say it's X or it's SX, right? Kita ada SX and SY. When it is the maximum, it becomes range. When this guy becomes the maximum, we call it as H. But if you don't want to label it as H and capital R, that's fine. But you have to know the name that the maximum displacement in the X is called range and the maximum height is called capital H or maximum height lah. And to get maximum H, you have to equate your equation to V equals to 0. Because this is the point that you are interested in. So therefore, that is your final position to find the maximum height. The final position, bukan actual final position. It's just that we divided the motion into two parts. And I said that V equals to 0 is the final velocity for our first section of the projectile motion. Okay, so and we know that, oh ni salah tulis. And we know that our acceleration in the X direction is 0. Okay, sebab obviously kalau kita berjalan pun, there's nothing pulling us to the right, there's nothing pulling us to the left. It's just us walking, right? But there is gravity pulling us downwards. So we feel the we don't actually feel it, but there is attraction going down, which is called the gravity, right? Which is how our feet is touching the ground. If there's no gravity, then I would be floating. I wouldn't be sitting on this chair. I would be floating. And entah macam mana nak buat zoom ni. So there is a downward motion called gravity, and it is a minus g or minus 9.81. There is no acceleration in the left or in the right. If not, then I'd be like constantly moving like that, right? So there's no acceleration in the X. Kalau letak acceleration in the X, rotan diri sendiri. Sebab yang ni macam common sense lah. Okay, so this is something that you need to remember. AX is 0, AY is minus 9.81. And whoever touches the angle gets the cosine. So here, your X touches your x-axis touches the angles, therefore your ux gets the cosine. So it's 50 cosine 30, and your uy does not touch the angle, so it gets the sine. So 50 sine 30. And the velocity in the x direction is equal to the ux. It doesn't ever change. Like I said before, it's not influenced by any acceleration. Therefore, the velocity is constant. What do we know about a constant velocity? When we have a constant velocity, our change in v is equal to 0. And acceleration or average acceleration is delta v over t or delta t. So we know that acceleration is 0 lah. because there's no change in velocity. So this is something that I want you guys to relate back to the first part of this chapter lah, which is linear motion. What was the topic called? Linear motion lah kot. I don't remember. Oh, linear kinematics yang kita belajar all these equations, right? Before we got to the linear kinematics, we had to learn about average acceleration, average velocity, and then baru kita dapat our linear kinematics. So this goes back to that part, the first part that we learned in our class. Kenapa kenapa velocity tak berubah? Because there is no change in velocity because of the zero acceleration. When you have a value in your acceleration, then you have a change in your velocity. This is something to think about je lah. But if you are already comfortable and you don't want to like remember like stuff from the first part, then just don't lah. But it makes sense, right? It makes sense. Acceleration 0, therefore velocity does not change. Okay, what else do I need to recap? Maximum height equals 0. Okay, so time. Displacement kita dah cakap dah. So time at this point is not the actual duration of the whole projectile motion. It can be half or it can be less than half. It depends on the question. In this question, it's symmetrical. The projectile motion is symmetrical. Therefore, I know that the t to reach the highest point is the same time taken to reach, from the maximum height to the landing point. So sama, time over here is the same as time on the right because it is symmetrical. But in most cases, your problems will not give you a symmetrical problem. Let's say this is a mountain and I'm up here and I throw a ball. So in this case, my ball will not be experiencing a symmetrical projectile motion. In fact, if I try to divide it, there's no place to divide it because it's not symmetrical. If I wanted to like indicate where my v equals to 0, of course, it's going to be over here. The v equals to 0 still exists, but the time taken to reach this point is not equal to the time from the maximum height to reach the landing point. So this is for symmetrical conditions. Okay, so now let's go back to our example yang kita tak habis ni. So that was my recap. Any questions, you can just interrupt me. Okay. Excuse me. So let's use red today. Okay. Kita dah habis sampai time and the highest point. Let me just go over this one. So ux is 50 cosine 30, uy is 50 sine 30, ax is 0, ay is our gravity minus 9.81 meter per second squared. Our Vx is the same as Ux. Vy is from the equation V equals to U plus AT. And I'm trying to find Vy. Therefore, everything needs to be in the y-axis as well. Except for time lah. Time tak ada, time is a scalar. So Vy, I'm trying to find Vy. Sorry, my Vy here is 0 because this is my final point here. I'm trying to solve for the first section of the projectile motion. Therefore, this becomes my final velocity. And then just substitute 50 sine 30 over here, minus 9.81. And I can find for my time to reach the maximum height over here. So I got 2.55. Substitute that into my displacement equation. Sy equals 1 over 2u plus vt. In this case, my v is equal to 0. I'm still trying to find the displacement over here, the displacement in the y, right? So this becomes 0 as well. Sama macam tadi, kat sini 0, kat sini pun 0 because it refers to the same time. So Sy equals 1 over 2, u, substitute 50 sine 30, plus 0, and then t, which is 2.55. Okay, so I got 31.88 as the maximum height. So the continuation to this problem is this. Try this, let the launching angle, speed be 30 and 50. Find the time of flight. Time of flight means the total duration of your projectile motion. I'm recording, right? Yeah. Okay, and then range is the maximum Sx, this is called t. Final velocity, like the actual final velocity, not like at the section. Kalau dia cakap final velocity, memang cakap pasal final velocity, the actual final velocity. When we divide it into sections, we are the only ones who know about the different sections of our projectile motion. The question doesn't care if you are dividing it into sections or not. So when they are talking about final velocity, they are always referring to the actual final velocity. Okay, so this is just V lah. V is asking for final velocity Vx and Vy lah, because dia tak specify. Therefore, kita kena cari the V from Vx and Vy. At time equals to t. At time equals to t, at the total duration. When I reach this point, right, my time is equal to t, my Sx is equal to r. What else? My Sy is equal to, what is it? Negative lah, something negative. Okay, ni tak penting. Kita nak tahu pasal range je. Range, time of flight, final velocity. Okay, so let's do this. What are the info that we have? We already know. Lah, merah tak sesuai. Sekejap. Let me use your black. Okay, so this is X and this is Y. So our Ux was 50 cosine 30. I'm just writing it back. Uy 50 sine 30. I'm not going to put the acceleration because we already know this. I want to find out this point. Okay. So what is the information that I already know at this point? I know that the maximum height, which is Sy maximum, right? I already know H is 31.88. Was it? 31.88 and the time is 2.55. Okay, 31.88 meter and the time taken to reach H is 2.55 seconds. What can I say about the total duration of time? How can I find it?
Times 2.
Times 2. Betul? Sebab it's symmetrical, right? You can use that shortcut. So 2t, so it's just 5.1 seconds. Okay, so that is our total time of flight. And everyone is okay with this so far? Kenapa darab 2? Okay ke? Yeah, symmetrical eh. So time taken to reach the highest point is the same time taken from the highest point to the landing ground. So t and t, so you have 2t. 2t, you get 5.1 seconds. So now we want to find out our Sx, which is our r, capital R. So Sx is over here, or I'm just going to write r. What is the equation for displacement in the x? Let's use the one that we used before, 1/2 u plus v t. What time should I put in here?
5.1.
5.1, because I am trying to find the displacement over here and the time that corresponds to this point is 5.1. Tak boleh pakai 2.55 sebab saya cari kat ujung ni. Kalau saya cari kat sini punya Sx, then saya pakai 2.55. But I'm not interested in that point. I'm interested in the landing point, which happens at time 5.1 second. So I use that time. Okay, so u 50 cosine 30 and the Vx is also the same. So this is just 2u, right? 2 cancels out with 2. T is 5.1. Okay, so u is 50 cosine 30 times 5.1. Can someone calculate that for me? So saya takut saya salah kira. U is 50 cosine 30 times 5.1, 220.84. Dapat sama tak?
Yeah.
Sama.
So we got the time of flight, we got the range. Now we want to find out what is the final velocity. Okay, so to find the final velocity, which is v, right? We started with v naught or u, we end up with v. So kita nak cari v, tapi kita kena tahu vx, kita kena tahu vy. So we already know what vx is. It's straightforward. This is like, in all cases, vx is your ux, right? Which is 50 cosine 30 or whatever the value is. This is a 0, by the way. Okay. Now we want to find out what is our Vy. Okay, so Vy, let's use the V equals to U plus AT equation. U plus AT, oh sorry, it should be G. This is Uy minus GT. Now, my question is, what should be my time here?
2.55.
2.55, sebab apa?
U D
Sebab-
Y.
Sebab apa?
Sebab VY.
Sebab dia Y.
Maximum height.
Sebab height. Okay, kita nak cari V dekat mana sekarang ni? Kita nak cari kat sini ke dekat hujung?
Ujung
Ujung.
Hujung.
What time corresponds to hujung?
5.1.
5.1.
Okay, like I mentioned to you before, kita kena, the time has to correspond to the place that kita nak cari tu. Kita nak cari kat hujung, kenapa kita nak cari dekat time 2.55 seconds, right? So this is something very important, and selalunya orang akan buat silap kat sini. I'm trying to emphasize this point to you lah. We are trying to find the V kat hujung ni, and the time taken to reach the end is 5.1. Do not use the time to reach the mid section of this projectile motion. Pakai masa dekat hujung. So it becomes 5.1. So this is equation. Vy equals to 50 sine 30. Oops. 50 sine 30 and minus, I need space. Yep. Minus 9.81, 5.1. Okay, my question is my Vy equals to 0 or not?
Yes.
Kenapa? Kenapa dia 0 Kalau 0 kat atas ni, bawah pun dia 0
No.
Yes.
Okay, so everyone is like confused. Bagus, this confusion is what I welcome. Maksudnya korang kena belajar lagi. Okay. So kita start dengan this velocity, and then kita reach a point where our V equals to 0. This is Vy, Vx does not change, right? Kita turun, we will be having a negative velocity because it's going down, and the value keeps on increasing. Kita nak cari before it touches the ground. Betul, bila dia cecah lantai, when it touches the ground, it indeed become V equals to 0. Everything becomes 0. But it is not part of the motion anymore. It's not part of the projectile motion. What we're interested is before dia jadi V equals to 0. Okay, that is the unknown here. So kat sini ada value, kat sini ada value, kat sini pun ada value. We're not interested when it touches the ground. I don't care if it touches the ground because that is no longer part of my projectile motion. So I want to know what happens before it touches the ground. And linear kinematics finds out the velocity before it touches the ground, because linear kinematic describes the motion. When it touches the ground, it's not part of the motion anymore. Okay, so with that said, even kat hujung, this V is not equal to 0, not necessarily, unless benda ni dapatkan kita 0 lah. So here we already have the value, so it shouldn't be equal to 0. So it's 50 sine 30 minus 9.81 times 5.1. So you get minus 25.03 meter per second. This is the Vy. what is my UI? Let's see. 50 sine 30.
25.
Oops. 50 sine 30, 25. Okay. Lebih kurang kan? But this guy is in positive. This guy is negative. Because we are having a symmetrical motion. Therefore, we start at approximately the same velocity and we end up with approximately the same velocity. Tapi ni don't use this shortcut. You have to show me this jalan kira. Don't use the shortcut Tolong cari the values using linear kinematic equation. Okay, but I'm trying to make sense to you that kita punya projectile motion ni symmetrical. Time to reach the highest point is t. Time nak turun pun t. Kat sini punya displacement is most likely the same as displacement on the right side. So the v nak naik is the same as the v nak turun. The difference is one is positive, one is negative. Okay. So we found out the final velocity Vy. Okay, so now we go to tekan dulu. Okay, so this is very messy. Let me rearrange this a little bit. Tak boleh rearrange. Tak apalah. Okay, so now dia nak cari velocity. So the same thing as we did before for vectors. It's a vector, right? So we have our v equals to vx squared plus vy squared. Then this will give you the magnitude. So our vx is 50 cosine 30. Okay, pakai kat sini tau, jangan ambil tempat lain pula. 50 cosine 30 squared. And then you have your minus 25 squared. Okay, this will give you your magnitude. And your theta, your angle of landing, your velocity punya angle landing is inverse tangent. Why is my pen like that? Okay, so inverse tangent Vy over Vx. Whatever that is, just know the equation. I think you can do the plug-in yourself. Okay. All right. So let's. Any questions about this one? So final answer kena ada yang ni Final answer kena ada yang ni dengan angle. It's a vector.
Betul. Saya confuse yang Vy ni dengan yang Vy tadi tu. Yang Vy tadi kan sama dengan kosong. Lepas tu yang ni kita dapat nilai.
Okay. Let's discuss that. Let me make this smaller. Kena buat housekeeping jap. Root. Korang faham lah kan walaupun tak ada dalam kotak. Okay. And again, I really welcome questions. Kalau tak, saya tak tahu apa korang tak tahu. Lagipun kita tak jumpa depan-depan. So it's hard. I don't know what your face expression is. Kalau muka korang blur, bolehlah saya terus ni kan. So basically, I don't know what you guys look like right now. So that's sad. Okay. Okay, let's talk about why for the previous example, it was 0 and suddenly why it has become a value, right? Okay, let's just use ping. Okay. So this is my projectile motion. I already know this. And the information that we have is this guy, 50 meters per second. This is our UV naught ataupun initial velocity, and the angle is 30. And I told you at one point dia akan jadi V equals to 0. And the V that becomes 0 is specifically Vy. Specifically Vy. At this point, the Vx is still Ux. At this point, the Vx is still Ux. At this point, the Vx is still Ux. My point here is acceleration in the X direction is 0. Therefore, your velocity does not change. Okay, so everyone should be okay with that, right? So Vx equals to Ux at all points. Okay, so that's the first point. Now, kenapa kat sini 0 And then we got a value of time, the time, bila saya baling bola, the time to reach the highest point, I took 2.55 seconds. And equation kita pakai tadi, V equals to U minus GT. The V kita equate to 0. And the U kita pakai this 25. And then this one macam biasalah, kita dapat T. So daripada sini kita dapat T equals to 2.55. Okay. So kenapa saya tahu nak kena letak kosong ni? Because this is the information that we needed to remember. Yang ni memang kena tahu. Maximum height, V equals to 0. Maximum height, V equals to 0. So anytime they ask you about maximum height, you know one thing, one condition that you need to remember for all maximum height, V equals to 0. Unless dia cakap dia start from a height of 100 meter, then tak bolehlah pakai the assumption that V equals to 0 tu kan. But when we have a projectile motion that goes up and goes down, information yang kita sendiri kena tahu kita sendiri kena ingat, kena tahu. To find the maximum height, you need to equate V equals to 0. And then kenapa saya cari masa? Kenapa saya cari masa? Because I needed this time to find the displacement. I want to know what is the displacement in the Y over here. Mula kita naik sikit, naik sikit, naik sikit sampai ke sini. Saya nak tahu dekat sini berapa displacement setelah masa dia 2.55. Kenapa 2.55? Sebab itu tempat yang V equals to 0. Kenapa V equals to 0? Sebab kita tahu V equals to 0 adalah tempat maximum height. Okay, so kenapa saya cari masa? Sebab saya nak tahu displacement. So using this time, I put it into my SY, which gets me H. So 1/2, U plus V, letak time 2.55. So apa yang saya dapat kat sini? Saya dapat H. I get this point. Kalau saya letak nombor lain, kalau saya letak time, let's say 3 second. Time 3 second. 3 second kat, dia akan pergi ke kanan lagi lah kan. What will I get for my SY? I will get this point. This is the displacement that I will get. If I put my time as 1, this is the displacement that I will get. So kenapa saya nak pakai masa kat sini? Sebab this is the point that I get the maximum height. The maximum height happens when V equals to 0. Faham tak?
Faham.
Faham So SY kat sini, SY kat sini. So SY berubah ikut masa. So saya interested dengan masa kat sini sebab sini adalah maximum height. So next step was kita nak tahu the total time, and dari total time tu kita akan tahu kita punya range, right? Oops. So total time untuk sampai ke hujung adalah twice the time, separuh lah. So darab 2 je lah. Oops. Darab 2, which is straightforward. Kita boleh pakai shortcut ni untuk exam if it's symmetrical. But you just say total time is equal to 2 times the T that you found for the mixed section due to the projectile being symmetrical. We accept that answer. Boleh. Kalau nak cari sendiri pun boleh pakai equation. Okay, so kita dah tahu kat sini 2.55. Therefore, I know untuk habiskan projectile motion ni, the time hujung ni is 5.1. Do I know the information about the velocity at this point? I know for Vx, but I don't know for my Vy. This is an unknown. It's not 0 because I want to know what is the velocity before it touches the ground. So it's not 0 yet. Okay. So, pakai balik equation tadi, V equals to U plus AT. And the V is something that we don't know. Apa yang kita tahu? Kita tahu kat sini je. Kat sini kita tak tahu. So, kita tak boleh letak kosong kat situ. The 0 only applies here. Okay? I don't want that. I want the V at time 5.1. So, U what is, apa nama tadi? 25, sorry, minus 9.81, 5.1, So the V is something that we want to find. So it becomes minus 25. Kau tak siap saja. Betul tak? Ada hilang dah. So that is what we got for our VY. Okay. So this is VY, VY, VY. Okay. Is that okay? Any other confusions?
Okay.
Okay. Ada soalan lain tak? Okay, lepas ni kita apply untuk problems lain. So I hope everyone is... Yep.
Yang sorry.
Tak apa.
Yang V tu equal Vx kuasa 2 plus Vy kuasa 2 tu kan?
This one, yes.
Itu cari displacement
Bukan, kita cari the velocity vector. Okay, remember I told you A vector is equal to Ax vector plus Ay vector. Do you remember this part in chapter 1?
Yes.
Kita resolve kan? So anggap A vector ni V, kita tahu Vx, kita tahu Vy. So cara untuk kita tahu magnitude vector ni is pakai Pythagoras theorem kan untuk cari A hari tu kan? Sama.
Yes.
It's the same thing except that now is velocity. So equation ni boleh pakai untuk semua vector. It doesn't have to be displacement, it doesn't have to be velocity, it can also be acceleration, boleh. Asalkan vector. So this is square root. Okay? Ingat kan? Kau tak ingat dah?
So kalau yang vektor ni dia ada dia punya ni kemudian R
Resultant.
dia punya garis resultant.
Yes, resultant dia is this guy. This is the resultant. Apa yang kita cari kat sini dalam table ni? Kita cari Vy, Vx. We are finding the components of this vector actually. Okay, because Vx is supposed to be in the x-axis, Vy is supposed to be in the y-axis. We don't know what the resultant is yet. So untuk cari V ni, you use the Pythagoras theorem to find the magnitude and the angle, the the tangent, inverse tangent tu untuk cari angle dia. So you get the angle something over here, below the x-axis, which is a minus angle. Faham tak? So this is the resultant here. So if kita started with a resultant and kita pecahkan kepada ux and uy, this is our resultant. Konon-konon lah. Kita assume the resultant lah. This is our ux and uy. Kita yang pecahkan sendiri, our punya vector. Lepas tu bila sampai sini, dia still dalam keadaan pecah. Kita nak gabungkan dia balik. Sebab soalan minta kan. Kalau soalan tak minta, saya tak bagi. Macam itulah. Faham ke?
Betul. Thank you.
So that's a really good question sebab dia relate back to the vector. So this should be, it should tie together lah. Okay, so I hope this is something that you appreciate lah. Betul? What do I want to say? Kaitkan vector chapter 1 in here because it is vector and it is what we are trying to do. We are resolving it into x and y components, which is what we learned in chapter 1. And then kita gabung balik jadi a single resultant vector. Okay, which is V. Alright. Okay, those are really good questions. I really appreciate them. Okay, so moving on to non-symmetrical projectile motion. So projected horizontally, we have an airplane over here. It's quite small. Let me make it bigger. We have an airplane here and it is projected horizontally from a certain height. Projected horizontally. This word is important. It means that we don't have a UI. This means UI equals to 0. It only has a value UX. This is what it means when it says the airplane is projected horizontally from a certain height. Now, immediately we know that the displacement is from the maximum height, macam ni. Dia start pada maximum and ada value. So kita tak boleh lah pakai V, this maximum height, V equals to 0 tu, because there is no lekuk ni, tak ada. Dia terus start pada atas, and daripada atas tu ada value of UX. Tapi UI dia kosong kan, so okay lah. So that's nice. Okay, so again, the question says projected horizontally from a certain height. This means the UI is equal to 0, the UX has some value to it. Ada tak tulis ni? Okay, UX dia 40, dia bagi kat situ 40. So UI and UX is 40. If I make this into a resultant vector, the U or the V0 is simply 40 with angle 0. Because that is what it is. It is a resultant 2. Walaupun dia ada X sahaja. Okay, but we're not interested in the resultant here. Kita dah tahu UX is 40, UY is 0. Acceleration in the X is 0. Acceleration in the Y is minus 9.81. We don't know what the final velocity is. We don't know what the time is. And we want to know what is the displacement in the X. And here it has given us the maximum height. So that's nice. Kenapa dia letak negatif kat sini? Kita start pada atas. Kenapa dia letak negatif? Why is it a minus 100? Why is it not just 100?
Because it's going down.
Because it's going down. Okay, is there another explanation except for it's going down? Tu betul. There's two explanation. Because its motion is going down, betul. Can we relate it to equation? Ada tak equation yang korang ingat? What is the equation for S? S equal to delta Y or delta X. What is the equation? How do you expand delta?
Y final.
Y final minus Y initial.
Yes, correct. Every time we have a delta, Y final minus Y initial. The Y final, what is our final displacement? 0. What is our initial displacement? Over here, it's 100. Tu kat sini 100 kan? So Y final 0 minus 100. This is how you get the minus 100. Another way of making sense of this situation is because the motion is going down. This is the shortcut that I told you. Going up, motion positive. Going down, negative. If you want to be sure, use the equation. You will always be right with this one. There's no guessing. Okay, so that is a minus 100. Or I'll just let it there. Let it be there. See. Aduh. Okay, just leave it there. Okay, so that is your S equals to minus 100 or your maximum height, H. Okay, so how do we find the Vx over here? Using the knowledge that we learned from tadi. Kita pakai balik semua. Macam mana nak cari Vx? Come on guys, Vx. Vx should be easy. Vx is a known condition.
Equal to UX.
Equals to Ux, yes, thank you. Vs equals to Ux. It doesn't change. Acceleration is 0. There's no change in the velocity. Okay, so Uy here is 0, great. What equation should I use to find my V? So we can't use V equals to U plus AT, right? Because there, in that equation, it has time. We don't know the time yet. So we have to use other equation. Maybe V squared equals to U squared plus 2AS. Can we use that? A boleh. S kita tahu. U pun kita tahu. So let's use that. So I don't know what V is. I'm trying to find V. U is 0 plus 2 minus 9.81. S is minus 100 over here. Okay, minus 100. Square root the whole thing. Okay, so what is my V here? Can someone calculate that for me? Sebab saya tahu saya akan buat salah juga kadang-kadang. Minus 100.
4.29.
Berapa?
44.29.
44.29, thank you. Okay. Okay, saya tak sempat tekan lagi, laju. So that is square root of that, 44.29. Okay, sama. So this is my velocity. Now, what is the direction of my velocity? Should it have a positive or a negative sign? This is Vy. Okay, negatif. Ada orang cakap negatif. Mana datang negatif tu? Mana datang? So yeah, it's going down, so it's negative. But mathematically, where did it come from?
Square root.
Square root, yay. Ada orang ingat.
Square root.
If we square root of 4, it can be plus minus 2. Minus 2 squared is a 4. Positive 2 squared is a 4. So this is where when you have a square root, you get two answers. You get a positive and a negative. And as I said to you before, smart humans choose the exact sign depending on the situation. We are going down, so it's a negative. Okay. So that is our answer, minus 44. So that's great. Now we want to find the time. How do we find the time? Can we use the first equation to find the time? Boleh ke tak?
Boleh.
Boleh eh? Okay, let's try it. Let me put it over here lah. This is just info. Okay, so T V equals to U plus AT. Okay, I'll do it here. So V kita dah tahu minus 44.29. Okay, so the V that we found earlier, which is minus 44.29, does it refer to this point or the point at the end? The initial point or the point at the end? It's called V. Hint.
Point at the end.
Point
At the end.
Kita cari V V is always the final velocity. And in this case, kita tak ada dua section. There's only one section here. So there's no like confusion going on sepatutnya lah. Okay, so minus 44.29, I am referring to the velocity that I got over here. Okay, so V equals to minus 44.29, initial velocity that we started with. In the Y direction is 0. In the Y direction, so UY, VY, AY. But to minus 9.81, I don't know what the time is. This is what I'm trying to find. So I get, I don't know, whatever that is. Okay, macam biasa, minta tolong. Mine divided by minus 9.1. What did you guys get?
4.51.
4.51, okay, sama. 4.51 seconds is the time taken to reach the end. How did I know that I reached the end? I used the V that I got at the end. This is how I know that I got the time at the end as well. Kalau saya pakai V kat sini, let's say the V over here is minus 30.
No, the money fall.
Okay. Nah.
Yeah.
Okay, bye. So minus 30. So let's say this is a minus 30, right? If I try to solve V equals to U plus 80, so this is 0. U tak berubah kan? U is always the initial. Minus 9.81 and I got something T. The time that I get refers to the time taken to reach this point. Okay, I hope everyone understands this point. When I use the velocity at this point, I get the time at this point. When I use the velocity at the end, I get the time at the end. Okay? Okay, turn down the volume please. Okay, so harap tak ada orang confused dengan yang tu. The velocity and time, everything, displacement, semua kena tempat yang sama. Kalau saya cari pakai masa kat sini, dalam equation displacement, saya akan dapat displacement kat ujung. Okay? Did we solve it yet? Oh no, belum. SX belum. T dah dapat, VY dah dapat. So the T taken to reach this point is the same time interval in the X because it's a scalar, right? So time is 4.5 second as well to reach the end. So with that information, I can find my R. Okay, the maximum X displacement. What do I want to use? 1/2 lah. U plus V times with 4.51. And U is equal to V. So this is basically 2U. Boleh cancel out. U times 4.51, 40 times 4.51. 180.4. Units is meter displacement. This is your displacement in the X, or it's called range, maximum displacement. Velocity when touching the ground. Okay, so the last question is asking us, what is the velocity when touching the ground? So we already know the Vx, we already know the Vy. What was the Vy? It's here. This is our Vy, so let's just do it. V equals to, kita dapat something like this, Vx, Vy, kita nak tahu V, which is this dude over here. This is our V. Okay, kita nak tahu magnitude, kita nak tahu angle. So V is equal to Vx is 4, sorry, it's not, yeah, it's 40 squared. This is minus 44.29 squared, square root the whole thing. Can someone calculate this for me? And the angle would be theta inverse tangent and minus 44.29 over 40. And I need answer for this one as well. So berapa angle dia and berapa dia punya magnitude?
Negative 59.67.
Ini angle kan?
V.
Oh, V, okay. V. Negative
59.
or 59? Negative
59.68.
59.68. Okay, what about the angle? Okay, anyone got the angle yet? So tekan calculator pun. Kita nak discuss pasal angle factor. Berapa? Negatif?
Negative 0.84.
Oh, kecilnya. Awak pakai, oh betul lah, dia bahagi pun lebih kurang. Okay, let me just double check. Bukan saya tak percaya, tapi bahagi 40. Saya dapat lain. Sekejap. 44.29 divided by 40. Saya dapat 47.91.
91.
Awak punya calculator dalam radians ke?
Dalam radian.
Okay, tu satu lagi benda kena make sure in degrees. Kita belum sampai chapter radians lagi. Okay. So minus 47.91. Lepas tu korang panik macam, ada radians punya calculation ke? Yes, ada. Kemudian. Okay, so kita dapat angle ni negative, right? Negative angle indicates that the angle is below the x-axis, which is what we are expecting. Kenapa? Sebab kita always refer to our vector with respect to the x-axis, and this is our imaginary x-axis, and this value is 47.91. Do I have to put in the negative? No, because it's already below the x-axis. The negative indicates it's below. So how would I write this answer? So my vector is the V is, boleh the V is 59.68 meter per second. Do not forget units. And 47.91 degrees below x-axis. Ataupun you can ignore this and you just put the negative. We understand that you know it's negative lah. But kenapa tadi your friend give me a negative? Why did I not use it here? Is it really a negative or is it a positive or is it What is it? Okay, so equation ni, does it give us the direction or not?
Yes.
Equation Pythagoras ni, dia bagi kita direction.
No.
Okay, kenapa tak bagi Kita ada square root ni, plus minus. But why does it give us the direction? And meaning to say that I do not depend on this equation to get my direction lah. Sebab equation ni gives us the magnitude. So with that said, I only care about the value from this equation. And I should have written it like this. Macam ni sebenarnya equation dia. So always remember when we use the Pythagoras equation, it gives us the magnitude, it does not give us direction. Macam mana kita dapat direction? Daripada sini. So this guy, kita boleh ignore dia punya positive, negative Untuk this guy je, this magnitude equation sahaja. You guys can ignore the positive, negative of the square root. Because sebenarnya equation ni, rupa dia ada modulus sign tu. Okay, so you get the 59.68. But I appreciate that you tried the minus too. It makes sense, right? To put in the minus because it's going down. But this gives us the magnitude only. And this guy gives us the direction. Okay, so I hope that's clear for everyone. What time is it? Yeah, habis dah masa. Any other questions before I end class? Any questions about this magnitude and direction? So everyone's okay?
No.
Okay. All right, so don't forget to tick your attendance if you haven't, and I'll see you guys next week. Bye-bye. Take care.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Bye.
Thank you,
Thank
Doctor.
you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor. Have a nice weekend.
Thank you. You too.